Jadi ada 3 prinsip utama yang digunakan untuk menganalisis lemak, untuk mengetahui ciri-ciri lemak. Yang pertama adalah solvent extraction, yang kedua non-solvent extraction, dan yang ketiga adalah instrumental method. Jadi sebelum kita boleh menganalisis lipid, kita terpaksalah mengekstrak dahulu lipid tersebut daripada sampel makanan. So extraction of oil from foodstuff by homogenizing with a solvent combination such as hexane isopropanol or chloroform methanol. Jadi dalam amali pun kita ada buat Soxhlet extraction, kita gunakan pet heater. After that, the solvent will be removed using a rotary evaporator. And as I have mentioned before, if you want to minimize the lipid oxidation, you can try to put the sample in nitrogen, adding antioxidant, avoid from the light, avoid from the hot temperature, okay. And then bulk fat and oils, the oils that has been extracted from the source, from the food, or from the other source, let's say from nuts, from sunflower oil, sunflower seed, from pumpkin seed, whatever. So normally after we extract, we will treat. Okay, we will treat or refine the oil or the lipid, maybe through several processing, such as degumming to get rid of the gum, neutralization to neutralize the oil, bleaching to get a nicer color, deodorize to get rid of the not so nice odor. And sometimes they have to do some more treatment, for example fractionation to fractionate the oil further, winterization also to separate the oil into different component by using solvent and low temperature. Interesterification, sometimes you do this because you want to modify the fatty acid content, or maybe you can do hydrogenation because you want to get rid of the double bond, you want to replace the double bond with the hydrogen. So it depends on what you want with the lipid or with the oil. So sample preparation, all sample must be clear and free from sediment. And then if needed, we also can dry the sample. And also, as I mentioned before, we really don't want any oxidation on the sample, so we shouldn't expose it to heat, light, or air. So this is the list, some not complete, but the list of analysis that you can do for pure lipid. This one you cannot do on food sample, but you have to do on pure lipid, or we call it bulk oil and bulk oils and fats. Okay, so mainly you are just analyzing the pure lipid, nothing else in there, just lipid. So you can determine the refractive index, melting point, smoke, flash and fire points, cold test, cloud point, color, iodine value, saponification value, free fatty acid and acid value, solid fat index and solid fat content, consistency, and polar components of frying fat. First, we're going to discuss about refractive index. So, refractive index is a term that is defined as the speed of light in air or vacuum divided by the speed of light in the oil. So basically we use a refractometer to measure refractive index of oil or fat. So for oil we use lower temperature, because for oil it is already in liquid form, so we just use 20 or 25 degrees Celsius. But for fat we must use higher temperature. Normally we use 40 degrees Celsius. So the application of refractive index is one to control hydrogenation, because normally for hydrogenation, when the fat is saturated, okay, normally hydrogenation is from oil become fat. Okay, so if you check the refractive index, if you got the result on refractive index, so you know whether the sample that we do the hydrogenation, whether is liquid or is in solid form. So Ri is low as iodine value is low. Okay, so Ri also indicate purity and the identity of the fat. Means, and also it provides means of identification, since each substance has a characteristic Ri. Number 2 is melting point. So we know already, but that in the fat there are a mixture of different triglycerides. So because of this difference in triglyceride, mixture of triglyceride, fat normally have different melting and crystallizing point range. It's not one value, but it's a range of values, because it's a mix of different triglycerides. So melting point is the temperature at which a fat changes from solid to liquid within the specific parameters of the test. So the melting point of individual fatty acids depends on factors such as chain length, number of double bond, and isomeric configuration, whether it's cis or trans. So capillary tube melting point, or complete melting point, or clear point, basically what we do is the temperature at which fat is heated at a given rate becomes completely clear and liquid in a one-end closed capillary glass tube. So basically when we heat the sample, it will become liquid. When we heat the fat, it will become liquid. This is one type of melting point. They call it capillary tube melting point, because they are using capillary glass tube. Okay. They also have analysis. They call it slit melting point. For slit melting point, the temperature where only a few percent of the fat is in solid fat. Temperature at which a column of fat moves in an open capillary when heated. So basically they are using different type of apparatus to get the result. And then we have dropping melting point. Temperature at which sample flows through a 0.11 inch hole in a sample cup placed in a specialized furnace. So this one you need a furnace and you also need a sample cup. Okay, so different apparatus used will give you different type of melting point result. And they also have Wiley melting point, whereby it gives a few degrees higher temperature than the sleep melting point. Temperature at which a disk of fat is suspended in an alcohol water mixture of similar density change into a sphere. Okay, this one also you need the different condition to get this result, Wiley melting point. So let us see the difference in melting point between the fatty acid. This is all saturated fatty acid. So we have fatty acid with C4, C6 until C26. And if you see the trend of melting point, you can see that with the increase in the carbon, number of carbon, there is an increase as well in the melting point. Okay, so the melting point of saturated fatty acid increases with chain length.